Example 10, here we go. Cosine 4x times cosine x equals sine 4x times sine x. I'm not going to lie, folks, this one is really tricky, and the strategy for solving this one is one that you can find in the textbook. And for you to do this one without watching this video first or without looking at the textbook, that would be pretty tricky. So I'm going to follow a similar strategy to what I've done in a lot of these other problems where we're solving equations, and I'm going to try and get a 0 on one side. I'll do that by subtracting the right-hand side from both sides of the equation. That'll give me cosine 4x times cosine of x minus sine of 4x times sine of x equals 0. And I'm not sure how many of you would see this without some input from me or the textbook, but this looks a whole lot like the formula for cosine of alpha plus beta. Remember, the cosine of alpha plus beta is cosine alpha times cosine beta minus sine alpha times sine beta. So in this example, the cosine alpha times cosine beta minus sine alpha times sine beta is what we have here. So that means that alpha is 4x and beta is x. So we can rewrite this problem as cosine of 4x plus x equals 0. And now this really isn't too bad. That is cosine of 5x equals 0, and we're going to go ahead and use u substitution. We'll let u equal to 5x. And then when we use that u substitution, we have cosine of u equals 0. We know that u has to be equal to pi over 2 plus pi k, because the cosine of pi over 2 and 3 pi over 2 are 0. So now we're going to go back and substitute in 5x for u, and we get 5x equals pi over 2 plus pi k. I'm going to go ahead and actually rewrite this right-hand side as pi over 2 plus 2 pi k over 2. I multiplied by 2 over 2, so I have a common denominator. And now I have 5x equals pi over 2, pi plus 2 pi k over 2. And the reason why I'm doing that is it's going to make it easier for me to come up with a list of values for x. But first I have to divide both sides by 5. So that gives me x equals pi plus 2 pi k all over 10. Now I'm looking for solutions on the interval from 0 to less than 2 pi. I know that 2 pi equals 20 pi over 10. So I want to stay under 20 pi over 10. We'll go through some k values here and see what x values we get. If k equals 0, then we get pi over 10 as a solution. If k equals 1, then we get 3 pi over 10 as a solution. If k equals 2, we get 5 pi over 10. 5 pi over 10 is the same as pi over 2, so I'm going to write it as pi over 2. If k equals 3, we get 7 pi over 10 as a solution. K equals 4, we get 9 pi over 10 as a solution. K equals 5, we get 11 pi over 10. Hopefully you see the pattern here. We're going up by 2 pi in our numerator each time because we're adding 2 pi k each time. We're adding 2 pi each time k increases by 1. When k equals 6, we have 13 pi over 10. When k equals 7, we have 15 pi over 10. That's the same as 3 pi over 2. When k equals 8, we have 17 pi over 10. And when k equals 9, we have 19 pi over 10. And if I were to go up, hold on folks, that's 19 pi over 10. If I were to go up to k equals 10, then I would have 21 pi over 10, and that's outside of the interval we were told for our solutions. So I know this is kind of crazy, but we have a comma-separated list here for all our solutions. If the pattern throws you off, don't forget that this was the same as 5 pi over 10, and this one was the same as 15 pi over 10. But there's our answers. Hopefully you don't have too many in WebAssign where you got to enter 10 different values. Let's move on to the next example. All right, folks, let's see what we can do with this one, number 11. Same directions as the previous problem. We got secant cubed of x plus secant squared of x equals 4 secant x plus 4. And this one, nothing jumps out at me as a solution strategy right away. So I just see some things on the left and right that look like GCFs. So I'm going to go ahead and factor the left-hand side and the right-hand side. So over here on the left, I'm going to have secant squared of x times secant of x plus 1 equals 4 times secant of x plus 1. And I now see that I have secant x plus 1 as a factor in both the left-hand side and the right-hand side. And I know you might be tempted to divide that out of both sides, but remember, we should never divide by anything that could equal 0. So we're gonna try something different than that. We're gonna go ahead and subtract 4 secant x plus 1 from both sides. So that'll give me secant squared of x times secant of x plus 1 minus 4 times secant of x plus 1, and that equals 0. So I've already factored one time in this problem, but I can factor again, and the reason why is because I still have a GCF in each of these terms. So when I factor again, I'm going to take secant of x plus 1 as one factor, and then the other factor will be secant squared of x and minus 4. Okay, so really I had to factor 2 times here to get down to where I had a single product. I have this term times this term, it equals 0, and from this point we should be comfortable with the zero product property to say I'm going to set this term and this term equal to 0, and those will be my solutions. So we'll start with this one. If I have secant squared of x equals 4, that means the secant of x equals plus or minus 2. Remember, when you subtract the square roots, you have to consider both positive and negative. So when I take the square root of both sides, it has to be the plus or minus square root of 4. Okay, so secant of x equals plus or minus 2. Secant of x is 1 over cosine. So that means the cosine of x equals plus or minus 1/2. And I know values on the unit circle that'll have that. That occurs at x equals pi over 3, 2 pi over 3, 4 pi over 3, and last but not least 5 pi over 3. So those 4 values will turn this factor, secant squared of x minus 4, into 0. Therefore, those are 4 solutions to this equation. Now let's go back and look at this other factor. I have secant of x equals -1 because I'm really solving the equation secant of x plus 1 equals 0. So this means I have cosine of x, which is the reciprocal of secant, is going to be 1 over -1, and that's kind of ridiculous to write that. I'm sure that you all realize that's really just -1, so I'm going to write it as -1. And when does the cosine equal -1? That occurs at x equals pi. So we really have four solutions to this equation. They are those guys right there and this lone value down here. And WebAssign will probably ask you to enter those in a comma-separated list. WebAssign doesn't care if they're in any kind of increasing or decreasing order, so it doesn't really matter how. You enter them as long as you get those five. All right, folks, we're going to move on to question 12. It is the final one we have to do in section 10.7. In fact, that's worth a quick round of applause because there's been a lot of these problems. I appreciate your perseverance and sticking with me through all these. Okay, so let's go ahead and get cracking on this problem. Okay, so taking a look at this problem, first thing I'm going to do is I'm going to rewrite it as 2u equals 1 minus u squared. And I'm just trying a u substitution strategy here to see what happens. I can rearrange this to get u squared plus 2u minus 1 equals 0. And what happens with this one, and I'm only showing this to show you a strategy that doesn't work. I could try to solve this like a quadratic. There's a hidden quadratic in here that looks like u squared plus 2u minus 1 equals 0. Unfortunately, this thing is not factorable. I'd have to use the quadratic equation to solve that. And if I did use the quadratic equation to solve that, I would see that u equals 1 plus or minus root 2. Unfortunately, I don't know if I let u equal tan of x, I don't know any x values that give me a tangent ratio of 1 plus or minus root 2. So unfortunately, this strategy isn't helpful. I just showed you that because sometimes solving things like a quadratic is very helpful. But what I'm going to do here is it violates something I've been warning you about all throughout section 10.7. I'm going to actually divide both sides by 1 minus tan squared of x. And I know right now that you're all shocked and disappointed in me. But we will get to a point where you'll understand why I'm doing this. Now, I've warned you not to do this because what if 1 minus tan squared of x equals 0? Well, in this case, we bypass that. And I'll show you why here in just a second. We got 2 times tan of x divided by 1 minus tan squared of x equals 1. And why is this okay? This, folks, is a hidden trig identity. And I'm going to give you a second to see if you can remember which one it is. I'm going to tell you that it's not one you had to memorize. So, which one is it? If I go back to section 10.4, all the trig identities we learned, hey, look at this right here. It's tan of 2 theta. Tan of 2 theta equals 2 tan theta over 1 minus tan squared theta. So that was kind of buried in this problem, and it's a tough one, I'm not going to lie. So what we now know is that because this right here equals the tangent of 2 theta, I can now say tan of 2 theta, or 2x, equals 1. Okay? So that's a double angle identity. 2 tan x over 1 minus tan squared x equals tangent of 2x. Well, now this problem really isn't too bad. Let's go ahead and look at our u substitution now. I'm going to let u equal 2x, and I'm going to say the tangent of u equals 1. So let's go ahead and solve this piece right here. When is the tangent of u equal to 1? Well, let's see. I know that tangent ratio is positive. This is a positive 1. It's positive in quadrant 1 and quadrant 3. So u is going to equal to pi over 4 plus pi k. Remember, the plus pi k gets me pi radians, or 180 degrees away from my original, rotated away from my original solution. So if I have u equals pi over 4 plus pi k and u equals 2x, I can now solve this equation. 2x equals pi over 4. And instead of plus pi k, let me write this as pi over 4 plus 8 pi k. Oh, hold on. There's a mistake. Plus pi k over 4. 4 pi k over 4. Okay, so by writing that, I can consolidate this solution and write it as pi plus 4 pi k all over 4. That looks ridiculous with that 4 there. You deserve better, so I'll write it right here. Okay, so let's make sure everybody understands that. Solution was u equals pi over 4 plus pi k. If I multiply pi k by 4 over 4, I can rewrite it as pi plus 4 pi k all over 4. That now equals 2x, which was my original u substitution. Let's solve this for x. I divide both sides by 2, and I get x equals pi plus 4 pi k all over 8. Okay, so now I have a general solution, but I need to list all solutions that are on the interval from 0 to 2 pi. So I'm going to go ahead and set up a table here for k and x and see what values I come up with. Remember, 2 pi equals 16 pi over 8. So once I go up to 16 pi over 8, I've gone too far because I want to stay less than 2 pi. So let's just look here at k equals 0, 1, 2, 3, 4 and see what happens. So when I start with k equals 0, I get a solution of pi over 8. When I go with k equals 1, I get a solution of 5 pi over 8. When I go with k equals 2, I get a solution of 9 pi over 8. And again, each of these numerators is increasing by 4 pi. Oh, hold on, folks. We got dogs are all fired up about something. Hold on a second, folks. All right, folks, crisis averted. It was literally just a car driving down the street. There's nothing to be alarmed about. We're going to persevere and finish this problem off. So, again, numerator increases by 4 pi every time k increases by 1. So when I go up to k equals 3, I get 13 pi over 8. When I go up to k equals 4, I get 17 pi over 8. Uh-oh, I've gone too far. We need to get rid of that one. Our solution to this equation is pi over 8, 5 pi over 8, 9 pi over 8, and 13 pi over 8. Now, folks, this one, again, I want to reiterate, I did something that I've warned you about for months here. Don't ever divide by something that could equal 0. But in this case, it was okay because what I identified was a trig identity. The hidden trig identity of the double angle formula for tangent, and I ended up with 4 solutions here. Can't include this one because it's outside of this interval. I do want to just do one last thing for you before I end this video, and I want to graph y equals 2 tan x and y equals 1 minus tan squared of x. This is a good strategy just to make sure your answer makes sense. So again, we got 4 answers here. We should see these graphs intersect 4 times. And sure enough, look at that. I have pi over 8, 2, 3, 4, 5 pi over 8, 6, 7, 8, 9 pi over 8, 10, 11, 12, 13 pi over 8. So those are the 4 intersections between y equals 2 tan x and y equals 1 minus tan squared of x. And folks, that's it for the chapter 10, section 10.7 videos. Thanks for sticking with me through all these example problems. I wish you luck in WebAssign.